Hello and welcome to my next video. Let me warn you up front that this is going to be a little intense, but stay with me. And I've tried to put everything in the slides, and of course, I have my text-based lecture notes. So hopefully, we can get this through this. So we're going to look at factor markets. Have a couple of videos on factor markets. So what we're looking at here is not a company and what they're producing and selling to the product market. So hopefully you remember way back that circular flow model of the economy. But what we are looking at is the supply and demand for factors: land, labor, capital, entrepreneurship. But we're going to stay mainly with labor, just as an example. So we're looking at the decision of a firm as to how many workers they will hire to maximize their profits. So we're looking at the input market. So from now on, when I say input, I'm talking about factors or resources, the things we're going to utilize in making the stuff we then sell in the product market. So that's what we're talking about. Now, believe it or not, the simplest model of a factor market would be one that is perfectly competitive on what they're selling in the product market, but also perfectly competitive in the factor market of labor. And again, I'll call that the input. So what the firm is selling to the product market, I'll call that the output market. And the factor market, the amount of labor that they hire in this specific example, that would be the input market. Now, it's critical you understand that in the factor market, the whole reason a firm demands labor is because they're going to use that labor to produce a good or service services, goods and or services. And so the demand for the product that they turn around and then try to sell will drive the demand for the workers that they want to hire. So we say that the demand for a factor is always derived from the good or service that the firm is producing and selling. Factor demand is a derived demand. So again, we're going to look at a competitive output. In other words, the product they're selling. Let's just stay with product, make it easier, rather than having to say goods and services every time. But we're also going to look at a competitive input or factor market. So here we go. So let's say we have this little small uh, model airplane company, and actually there's a whole bunch of them. And so there's so many of them that we're going to assume that they are selling these model planes in a perfectly competitive output market. But also, we're going to assume that it really doesn't take a whole lot of skills on the part of the workers to put these little model planes together. And so the skills are not highly technical, or most everybody can do it, is the point. And so there is a excuse me, a large potential pool of workers. So here's the key: the firm would want to hire the number of workers up to the point where the additional revenues, that's marginal revenue, brought in by hiring one more worker just equals the going wage rate. That will maximize the firm's profits. So we're looking at profit maximization not from the output perspective, marginal revenue equals marginal cost of the good we're producing and selling, but from the input market. How many workers do we want to hire in order to maximize our profits? Well, again, remember the demand for the workers is derived. So the actual demand, and we'll see that here graphically a little bit, but the actual demand for that worker would be called the marginal revenue product. And the marginal revenue product is the price of the output good times the marginal product of that last added worker. So again, what is that additional worker that we're going to hire? We're thinking about hiring. What are they going to increase our value of our product? We know the product we project will sell at a certain price, and how much will that additional worker produce of the product. So together that shows us how much total revenue will be uh, uh, increased by, so that's the marginal revenue, by hiring that next worker. So here's a typical, actually, I made up the numbers. If you go way back to the production and cost videos, you'll see that this is a total product or total physical product curve. And so I'll give you a minute or two, and I'm looking up because my monitor where I'm doing this today is a lot higher. So uh, this the data, and I guess I need to explain what's going on here. So N here's the number of workers, and Q is the number of planes that are produced. Of course, it shows you right here. But make sure that's clear. Now, this would be per unit of time, so we're going to say per shift, per 8-hour shift or whatever the shift is. Okay, now let's recall, this is good review, so let's recall how we calculate marginal product. Remember, marginal product is the change in total product divided by the change in the number of workers in this case, since we're talking about workers. Marginal product is MP, little delta sign is change in, TP is total product, N's number of workers hired. So let's suppose that the planes sell for $10 each. All right, well, again, recall the marginal product curve. That comes from that total product curve, the slope of the total product curve. We look at the change in the total product divided by the change in the number of workers. And so here's what we have. And remember the idea of diminishing returns, it would kick in at the point where this went from being flat, the marginal product curve, to having a negative slope. That portion that is experiencing diminishing returns, that is the demand for labor curve. And I'll explain that in a little more detail later. You hear a lot of people talk, oh, we're entering into a period of diminishing returns, like that's a negative thing. Well, yeah, each additional worker is adding less than the previous one, but they're still adding is the point. And so diminishing returns is where the firm actually will always operate. It's not some point they'll try to avoid, some area they'll try to avoid. It's actually where they'll always operate. So if we take the number of workers, the marginal product, and the price, well, if we multiply the price by the number of workers, by the marginal product, that's where our marginal revenue product comes from. Okay? And so if we plot that marginal revenue product curve against the number of workers hired, lo and behold, that is the demand curve. That will determine how many workers we're going to hire in order to maximize our profits. Well, that's part of the equation, demand and supply. So how do we determine supply? Well, recall, especially from a PC, which is what we're talking about, that the marginal cost curve is the same thing as the demand curve. Remember, demand is perfectly elastic in a PC output market. So we can hire all the workers we want, unlimited pool, at $100 a shift. So therefore, the marginal cost of hiring one more worker, in other words, for each worker we hire, we're going to have a higher cost of $100. This is called the marginal factor cost because we're looking at the input market. So let's think about why we're always going to operate in the diminishing returns region. Certainly, marginal factor cost equals marginal revenue product at this point, but the problem is that's actually a loss minimization point, or actually a loss maximization point, to be correct. So if you hire more workers, they're going to add a lot more to production than they are cost. This is the cost. And so this has to be profit maximization, not this point here. So let me backtrack to the verbiage of that. So the second intersection of marginal revenue product and wage rate will be the profit maximizing level. The first intersection where there are increasing marginal returns would not be profit maximization because hiring more workers causes MP to increase, not decrease. Hope that was as clear as mud. So we can see from this point of intersection right here that this is approximately 14 workers. So MRP equals MSC would be at the point of about 14 workers. And so 14 workers hired, they cost $100 per shift. So the cost for the 14 workers hired will be $1,400. 14 of them hired at $100 a shift. Now, from the total product graph, we can see that 14 workers will produce 190.4 planes roughly. They sell for $10 each, so total revenue would be the 190.4 times $10. Now, what we're looking at here on the $1,400 per shift, that's the variable cost. That's the total variable cost. So we have to have some, we're in the short run. So let's say that the other variable cost and fixed costs, so there would be more variable costs than just the workers, but we're going to lump that together and say that that's $1,400 a shift. Excuse me, $400 a shift. So total cost would be $1,400 plus the $400, so that's $1,800. So total revenue is $1,904, total cost $1,800, and so we are earning $104 per shift. Now, if the total variable cost alone exceeded the 1904 shift, then the firm would just totally shut down. They can't even pay their workers and other variable costs. However, if in the short run the total variable cost is less than 1904, and total cost is greater than 1904, in other words, the firm would be earning a short run negative profit, a loss, but they're still earning enough to pay their workers and other variable costs. They'll continue to operate in the short run. Recall those concepts back in production and cost and the market structures. But you might ask, where do we come up with $100 per shift? Well, supply and demand. So we're looking at the overall market supply and demand for labor. Now, again, let's suppose there's 1,000 very small firms operating across the country. They produce exactly the same model airplane, just to keep it simple on a PC, perfectly competitive input and output. So each firm represents one thousandth of the market. This would be the output market. We're talking about selling the model planes. Market demand would just be the sum of all the demand for the workers. So that's the input market part. Okay. And so we could just scale up by 1,000. This is thousands now to get the market demand. Now recall in the short run, for the representative firm is the marginal cost curve above the average variable cost. And so the market short run supply curve would just be the sum of all the firm's supply curves. So let's just come up with a supply curve for the market. So the supply of labor, this would be all the workers. How many workers are willing and able to work at various wage rates? But remember, there's a huge amount of them. And so the intersection of supply and demand at the market level sets the number of workers totally that will be hired. So for the entire industry, it's 14,000. Each firm will hire 14 workers and pay them a wage rate of $100. So that intersection of market demand and market supply will determine the overall market wage rate. And then in a PC, remember the firms have to take the prices given, and the price here's the input, the factor market wage rate of $100. They also have to take the $10 they're selling the planes for as given. They're price takers, not price searchers. And so the competitive firm can hire or buy, if you will, all the workers they wish at that going market wage rate of $100. So that's where we came up with $100. Now, I've already talked about the marginal factor cost, and we know that if it's competitive on both the input market and the output market, then the market wage rate will equal the marginal factor cost. All right, I hope you stayed with me on looking at the factor market, specifically labor, where both the input, that's the factor market, and the output, that's what we're selling, the product market, if you will, selling to the product market, where they're both perfectly competitive.